Hello everyone, how are you doing? Welcome to an algebra tutorial video learning how to factor polynomials using multiple steps. What I'm getting at is we've learned throughout this whole video series lots of different ways to factor, how to take trinomials, binomials, and even some cases polynomials with four terms and know how to break them down into smaller binomials multiplied. However, sometimes you have to use multiple steps or recognize that you may factor something once and then there's another part you can factor and then there's another part maybe you can even factor. So trying to utilize all of our factoring methods and factor stuff down as far as we can. All right, here we've got 3x to the fourth plus 6x squared minus 72. And right away what jumps out at you is probably that the fact we have x to the fourth and an x squared, and then there's no common term. So it's already different than what we've been looking at. However, there are some similarities we have here. But the first thing, and this is the part I really want to stress, is whenever you're factoring, whenever you're trying to break down a polynomial into smaller factors, the first thing you want to do is factor out the greatest common factor. Right now, looking at this thing, if I look at all three terms, they all have a common factor of 3. I'm going to go ahead and factor that 3 out. Let's factor it out in the front, and let's see what we got after we factor that 3. Well, we're left with x to the fourth plus 2x squared minus 24. And that's a little bit easier to work with now. Let's focus just on the part in parentheses. We factored out the 3. We got some simpler coefficients to work with. So always factor out the greatest common factor before you dive into more complicated methods. And sometimes it'll open up and just make things easier to work with. All right, now let's focus on this part, the trinomial I still have left. You may notice it looks kind of familiar, but instead of going from squared to the first term to the constant term, it's going from the fourth to the second term to the constant term. So it's still kind of descending in a pattern. And what you can do is we can do some substitution. We can say, okay, let's let x squared equal, let's use a. So any place there's an x squared, I can substitute an a, or in case of an x fourth, I can substitute an a squared. So I can rewrite this using this substitution as a squared, because if a equals x squared, then a squared has to equal x to the fourth, just using my exponent properties. So we're putting a squared in place of x to the fourth, plus 2a, because a is equal to x squared, minus 24. And let's make sure we don't lose that little 3 in the front. So now it should hopefully look a lot familiar, right? This is just a trinomial with a leading coefficient of 1. And so we factor it down by looking at, well, what is b? b equals 2. And c equals negative 24. So I need two numbers that multiply to negative 24 but add to 2. And as soon as I can find those two numbers, which by the way are going to be 6 times negative 4, and then 6 plus negative 4, those two numbers work. That gives me a plus 6 times a minus 4. And don't forget the 3 that we factored out at the very beginning. Okay, so let's review. Starting with my trinomial, we factored out the 3. Took what was left. Recognize it kind of fits a pattern, but it works easier if we substitute a equals x squared and a squared equals x to the fourth. And so we rewrote our trinomial now. Fits more of that quadratic, that a squared, a to the first pattern that we've been working with. And then we noticed it was a trinomial with a leading coefficient of 1. So we looked at our coefficients b and c, found two numbers that add to b and multiply to c, and we rewrote it out this way. But we're not done, right? We still have to make an equivalent polynomial. So we've got to go back and re-substitute what we substituted earlier. So anytime there's an a, I need to put back an a squared in there. So let's rewrite now. We still have the 3 in the front. but now we've got x squared plus 6 and x squared minus 4. So I just substituted the x squareds back in place of a. All right, this is looking pretty good. So this right here, this trinomial is equivalent to these two binomials and that constant all multiplied together. We've done a lot of work, right? We had to do some substitution, we had to do some factoring, we had to do some different stages of factoring. We're actually not quite done. If I'm looking at this thing now, I can factor this over here. I have a difference of 2 squareds. X squared and 4 is just 2 squared. The difference of 2 squares, if you recognize, we can rewrite it as x minus 2 and x plus 2. So it's one of those special cases of factoring. If I multiply these together, it gets me right back to x squared minus 4. But I still have x squared plus 6. And then I still have the 3 in the front. All right, at this point, I know I can't factor x plus 2. I know I can't factor x minus 2 any farther. X squared plus 6, I kind of may want to factor that, but it doesn't fit any of my factoring. If it's a binomial, I can only factor them if it's the difference of 2 squares, the sum of 2 cubes, or the difference of 2 cubes. I don't have that in that case. So I can't factor x squared plus 6. If I still got the 3 in the front, I'm going to call it good. That's as far as I can take it. This right here is my final factored form and is equivalent to the original trinomial that I started with. So there you go. Factoring polynomials using multiple steps. Notice we had to factor the greatest common factor. We had to use a new substitution technique, but it allowed us to factor the trinomial with a leading coefficient of 1. That's 2 strategies. And then we also had a difference of 2 squares. So we had a special case. We had 3 different factoring techniques that we had to use all in this one polynomial. Hopefully you kept them all straight, took down good notes, or even labeled down which ones we used. And hopefully this is a helpful example for you as you're doing some more complicated factoring.